Hi everyone, welcome back to my YouTube channel where I always talk about some of the good questions okay, which already has been asked in GATE examination. In fact, I will be bringing few questions which are most likely to be asked in GATE 2G after few months, right? Okay, so let's solve this question. Okay, question was asked in GATE 202, right? For 2 marks you can. Because nowadays questions are not being asked in sequence for 1 marks and 2 marks, right? They nowadays they started confusing us. Sometimes they give 1 mark question, after that you might get 2 mark questions, so that is you will not be able to realize that this is 2 mark or 1 mark, right? Okay, but we don't have to take care of these things, right? We don't have to worry about whether it is 2 mark or 1 mark. You can say that I have to solve this question and I don't know anything. Suppose because it happens in the gate examination that when you attempt the gate examination, you forget everything because you guys are not consuming actual content, right? From YouTube channels or okay, from the coachings, right? From different coaching where you pay huge fees, right? You think that your teacher is solving question, right? So if he's solving question and he's telling you the concept, right? So you think that okay, I will be able to solve question like this, okay, but it is not meant that the same question would appear in the gate examination, right? So you have to think yourself, not only dependent upon the faculty or a teacher, right? So let's solve this question first. Talk. So the question here is that consider the circuit shown in the figure, right? The input is given, that Vt is given, and that too in the form of sinusoids. In boots, the sinusoidal steady state current IT flowing through the current is shown graphically, that the time t is in seconds, that is obvious, right? The circuit element Z can be, we have to identify that okay, whether it is a inductor or a capacitor, right? Okay, you can see here is that the input is sinusoidal. Okay. This is one of the wonderful property, right? If the input is sinusoidal, the output should also be the sinusoidal, right? And only the amplitude and phase might differ. Okay, this is the property of LTI system. Any LTI system you consider, right? LTI system, linear time invariant system. Okay, if the input is sinusoidal, output should also be the sinusoidal and the frequency should be same. Input frequency as well as the output frequency should be same. Okay, and you have to also observe this waveform for okay, IT steady state waveform they have given here. This is the steady state response, right? Steady state. So they should have given steady state response in the form of sinusoidal, but they have given waveform. That is what the main picture is, and nothing else. You don't have to worry about anything, right? So you can see here this waveform. If you look at this waveform, so you can write mathematically, okay, waveform. This is a waveform kind of, okay, and this is the waveform. Magnitude, the amplitude is 1 by root 2 and the minus by root 2 minus 1 by root 2, 1 by root 2, and the phase is, they have given phase here. This is 0 and they have given phase here, that is pi by 4. I think pi by 4, yeah. You can say this is t equal to pi by 4 they have given. T equal to pi by 4. Now what you have to do here is, you have to write the mathematical form. So what can be I of t? I of t will be equal to 1 upon root sine t minus. So always keep in mind that if there is a time shift, time shifting is there, it is equivalent to phase shift, the frequency domain. Time shift in the time domain. There is a time shift in the time domain. You can also consider here that is basic thing of from the signal system. Xt, okay, is delayed by t naught. So output will be what? E raised to power. If we talk about the phase only, right? So let's take the Fourier transform of this. Will be x of omega e raised to power. If it is xt, so it minus j that omega t. So what you can do here is, so here you can see the phase is what? Uh, minus t naught, right? Minus omega t naught. Here the phase is what? Minus t naught. But in our case that the input omega, okay, what is the omega value here? Omega is with 1. You don't have to worry about that. The phase is going to be minus pi by 4. Your IT became, your IT, your input is what? Input is given as Vt, is given as sin t. You can write in the phasor form here. This can be written as 1 angle 0. Output is I of t, that is 1 by root 2 sin t. Here omega you can identify. Omega is what? The input frequency is 1. So it will be again 1. Output frequency will always 1, right? Because the input is this guy, the voltage, the output is this guy, right? This is the property of LTI system, right? Always keep this in mind. Okay, so in this question, what they have given here is they have given the plots as well as the network. That's it. They haven't given anything. Okay. This question already has been asked in the GATE exam. So needless to worry about that. You have to identify immediately. So this is given as pi by 4. You can write again the phasor form, that is I 1 by root magnitude, and this is going to be 5 by pi by 4 is the phase. I hope this makes sense. Okay, so what you can do now is you can say that what is Z? After all, you have to find the Z now. The question you can see, they are asking about Z information, right? They are asking about Z. What is going to be this element? So let me tell what is Z. Z is basically the voltage upon that you know. And right here, Z is going to be V is 1 angle 0 upon I. I is 1 by root 2 angle minus pi by 4. This under root 2 go up, right? Angle, you are getting the magnitude of this, right? So you will get the magnitude as what? You will get magnitude as well as angle here, right? So now you will get magnitude under root 2, and the angle will be what? Angle of G, what? Angle of G will be, this minus sign will go up, so it will be pi by 4. So what is total G? G is equal to R plus J omega L, you can say. Or so if this guy is 1 plus already 1 is given and this is 1. Okay, so your 1 plus 1 plus j1 will give you under root 2 as well as the angle pi by 4. Tan inverse 1 by 1, right? That, so you are getting positive angle here, okay, and there should be inductor. Option will be what? An inductor of 1 Henry. I hope this makes sense. So always keep in mind that this kind of question already has been asked. In the exam, you have to identify that this problem is from steady state, okay, response. The input is sinusoidal, right here. Any LTI system is there, right? Any LTI system is there. If the input x of t is, you can say that cos omega t, the output is going to be what? Output will be a not cos and omega t plus, and from where this a naught and theta you will calculate from the impulse response. Impulse response will be given here, right? You can say h of j omega, where you have to calculate this at omega equal to this guy. You can compute the amplitude, magnitude here, mod of yeah, at input, okay, and angle, and then multiply and add. That's it, nothing else. So I hope this question is, I mean, this solution is okay and you understood, right? So we'll meet in the next session. Thank you.